Hey everyone, a very warm welcome to all of you to my presentation. Let's do our introduction first. I am Nirbhay Saxena, a student of CSE first year diploma from Polytechnic College Dabra, and I am presenting over here to share the information I gathered about atomic structure of chemistry. So let's dig in. Alright, so as we all know, our topic is atomic structure. So, what is an atom? So, basically, atom is like a tiny building block of all matter. Everything you see around you, solid, liquid, gas, and even living things, is made up of atoms. Let's talk about some pointers. An atom is the smallest particle of an element that retains its chemical properties. Average size is 0.1 nanometer. Atoms are extremely light. There are about 118 known atoms. Those are also known as elements in the periodic table. An atom combines together to form molecules, which makes up all matter. Now, let us talk about Rutherford atomic model. Rutherford's atomic model states that an atom has a small, dense, positively charged nucleus at its center, where most of the mass is concentrated and electrons revolve around the nucleus in the empty space, similar to the planets revolving around the sun. So, Rutherford's atomic model explained in 5 pointers. In 1991, Ernest Rutherford proposed his atomic model after his experiment, which is also known as gold foil experiment. He discovered tiny particles which are dense and positively charged and has a positively charged nucleus at its center. Almost all the matter of the atom is concentrated in the nucleus. The electrons revolve around the nucleus in empty space like planets around the sun. Most of the atom is empty space, explaining why most alpha particles passes through the gold foil. Now, what is gold foil experiment? In 1909, Ernest Rutherford with Geiger and Marsden performed the gold foil experiment. They bombarded a very thin sheet of gold foil with fast moving alpha particles, helium plus 2. Observations. Most alpha particles passed straight through the foil. Some were deflected at smaller angles. Out of 20k alpha particles, one bounced back. So from observations, we have what conclusions do we have? Most of the atom is empty space. The atom has a small, dense, and positively charged nucleus, and electrons revolve around this nucleus, and most of the atom's mass is concentrated there. Now, this experiment gave the foundation for Rutherford's atomic model. Now, this was the Rutherford's atomic model. Now, let's talk about Bohr's atomic model, which is also known as Rutherford's Bohr's atomic model. Now, what is Bohr's atomic model? It states that electrons revolve around the nucleus in fixed circular parts called orbits or shells without radiating energy and can be moved between these orbits by absorbing or emitting a definite amount of energy. Sounds a bit confusing, right? So, I have something to explain you properly. See, this is actually the how the revolving is done. As you can see, negative particles are electrons which are in the shells, and shells are revolving around the nucleus, and this nucleus is proton and neutron. Yes, the nucleus has proton and neutron both, and electrons revolves around inside shells. So yeah, and right, let us see in more detailed. In 1913, Niels Bohr improved Rutherford's model by explaining how electrons are arranged. Main postulates: electrons revolve around the nucleus in fixed paths called orbits or shells, which I already told you guys. These orbits have fixed energy, so electrons in them do not lose energy. Electrons can jump from one orbit to another by absorbing or emitting in a fixed amount of energy, called a quantum. Energy is absorbed when an electron moves to a higher orbit and emitted when it falls to a lower orbit. Bohr's model explained the stability of atom and the spectrum of hydrogen. This is the most important point. Alright? So, charges inside atom. Wait. There are three types of charges inside atom: electron, proton, neutron. Electrons are negatively charged, protons are positively charged, and neutrons are neutral. Means they have no charge. Alright. And proton and neutron are present in nucleus, and electrons are present in shells, which also revolves around nucleus. Now, orbits or orbitals. Orbits, the concept of orbits is from Bohr's atomic model. Electrons revolve around the nucleus in fixed circular paths called orbits or shells. Each orbit corresponds to a fixed energy level, denoted by KLMN, or the principal quantum number n, which is equal to 1, 2, 3, whatever the shell is. Example: first orbit is equal to K shell. Usually we say first orbit is K shell, and it is denoted as n is equal to 1. Simple but not accurate. This is simple but not accurate. Why? Because electrons don't really move in a neat circular paths. Now, orbitals. They are a quantum mechanical model. Concept from the modern quantum mechanical model of atom. So, yeah, there are four types of different orbitals with different shapes. S orbital, which has spherical shape; p orbital, which has dumbbell shape; d orbital, which has clover shape; and f orbital has complex shape. Each orbital can hold up to maximum of 2 electrons with opposite spins. Electronic configuration of elements. Electronic configuration of elements is the arrangement of electrons in different shells, subshells, or orbitals of an atom according to the increased energy levels. It shows how electrons are distributed around the nucleus. Electrons fills shell in a specific order given by Aufbau principle, like 1s, 2s, 2p, 3s, etc. The maximum number of electrons in a shell is given by 2n2, where n is equal to shell number. Now, example: hydrogen is 1, so 1s1. Oxygen has 8 electrons, so 1s2, 2s2, 2p4. You can see the example. Now, there are three main principles that governs the electronic configuration. Aufbau principle, where electrons are filled into orbitals in the order of increasing energy. The energy increases as the sequence grows. And Pauli exclusion principle. No two electrons in the same atom can have all 4 quantum numbers identical. In simple terms, an orbital can hold a maximum of 2 electrons, and they must have an opposite spins. Hund's rule, which is also known as maximum multiplicity. When filling orbitals of the same subshell like 2p, 3p, etc., electrons occupy orbitals singly first. Like first we have to fill singly at in the orbitals, then we have to fill another layer of electrons in the orbitals. example is given. Now, important elements directly from the periodic table of chemistry. Now, these are very important elements according to our syllabus. They have the atomic mass and valency of first 30 elements. These are the most important ones. You guys can go through with that. Now, quantum numbers. Quantum numbers are a set of 4 numbers that describe the position, energy, shape, orientation and spin of the electron. In an atom, they give the complete address of an electron. The 4 quantum numbers are principal quantum number, which is n, azimuthal quantum number L, which is subshell or shape we can say. Magnetic quantum number is m, which is orientation of orbital, and spin quantum number is s, which is spin of electron. Now these are explained in details, you guys can see. Alright, so with this, thank you so much for this little explanation. Alright, thanks.